Hello. Good evening. Welcome to Module 3. Hope everybody's staying warm and safe. I guess there's a storm out there tonight. Hopefully it won't affect our stream, and we'll get through, and the internet tubes will be okay. Again, I hope everybody's doing okay. It's great. It was great to see some of your work last week. I'm still making my way through that, so you should see grades starting to update as I get through those. But nice job on that. So by now, I mean, you kind of have the idea of the pattern of the class. So this module, you'll be proposing another at-home experiment, different from your first one. For that, now you should have a good sense of what works, what doesn't, what you want to do at home. If whatever you did the first module kind of sparks your imagination to investigate something further, that's fine. You don't have to totally do a separate, like a completely separate experiment. You can keep working on what you're working on, just like different aspects of it, if that makes sense. So just propose it, whatever it is that you want to do. If you're not sure, if you don't have any ideas, then you also now have access to all the discussion board posts where people have showed you some of the stuff that they have done. Again, you can't do the exact same thing that someone else has done. You can do the same basic process, but I want you to think of a different way to change it, a different way of investigating it, so that by the end of the semester, we have this like big body of knowledge of all the stuff that everybody has tried. So, if somebody if somebody did a chemical reaction using a couple of reactants and then they looked at varying the ratio of the reactants, maybe you can vary something else. Like maybe you can substitute a reactant, or you can look at different amounts, small amounts versus large amounts. You can look at temperatures, do things at different temperatures. All of that could be a possibility. The materials there's a lot of things to choose from, as you can see from what everybody did. The other thing is just make sure that you submit the proposal with all of the safety information. Even though a lot of these things that you find on the internet say like, oh, it's for kids, or like using household everyday stuff can sometimes be dangerous, especially when it's mixed in ways that it's not intended to be mixed. So make sure that you're looking up safety information and using that as part of your proposal. All right, as usual, I've got the chat open, so if you've got any questions, you can send them over. And so tonight I'm going to just kind of go through quickly the assignments and the plan for the next couple weeks, and then we will get into measurements, which is one of the main topics for today. All right, so do that. All right, so you see for this week, or these 2 weeks, there's two major topics like we would do in a classroom. One is taking measurements properly. That would be more of a lab skill, but it's probably something that's new to a lot of you. So we're going to spend some time on that tonight. Then we're going to look at drawing structures, chemical structures. We're going to focus on organic molecules, which are molecules based on carbon. And we're going to look at some different ways of drawing those structures. This is also something that is likely new to a lot of you. Some of this is generally introduced in an organic chemistry class, so if you haven't taken that before, this will be new. And there's some good practice material and stuff for you to do there. All right. So then, so those are the main topics: drawing molecules, measuring, and then distinguishing polarity, polar versus nonpolar. Now, depending on how things go this week and next week, we may push that last bit off a little bit. I don't want these streams running into these like marathon multi-hour sessions. I don't think anybody wants to sit and listen to that. So if it starts to get a little too long, we can move that to the next week. But I think we'll be okay if today we focus on measurement, Friday we focus on drawing structures, and then Monday the polarity. That should take us through the module okay. All right. So the assignments, which you can see down here, there's a worksheet where you practice drawing organic structures. It's actually kind of a section from a textbook that you can also read to help you out, and we'll go through that more on Friday. There's another activity worksheet like you did last week, this time focusing on properties of organic molecules. That's talking about the polarity and boiling points. There's another article report, a proposal for the at-home experiment, and then your lab, which this week is going to use equipment from your kit. Finally, there will also be a quiz, second quiz. Okay. So I guess we'll take a look at the lab first, and then we'll get into some of the skills that you're going to need for doing that lab. All right, so here's the lab. Now, of course, ideally we would be doing this in lab, so you could actually like do all this stuff. But because we have the lab kits, hold on, I think my cat stole my lab kit. Just a second. Okay, just moved it over a little bit. Because we have lab kits, we have at least one important measurement tool, two actually. But I think one of my kids stole the other one. But we have these graduated cylinders, and then which you probably maybe used a little bit of in the chromatography a few weeks ago. You also have the small beakers, so you can use those as well for measurements. And then you have the ruler. Now, I believe the lab here refers to 3 rulers. And we were not able to get all 3 of those for the kit in time. So if you can find a couple rulers in your house, I bet you can, even if you don't physically have them. That can include ruler type apps. So you can use your phone as a ruler. Sometimes if you look at the side of a tool, like a multi-tool, like a Leatherman or something like that, they'll have a ruler on there that you can use. You can also just print a ruler from online. Even if it's not quite the right size, it'll work for this lab. So you just need like 3 different rulers. And so this lab's going to take you through some basics of measurements using the international system of units, the prefixes like kilo, mega, centi, milli, stuff like that, and understanding the differences between those. You've probably heard this kind of stuff a little bit before. What I want to focus on and what is new is how to take measurements using a measurement tool. So if you see something like this, this graduated cylinder, how do we actually write down that measurement, and is it important? The answer to is it important is yes, but let's look at why and how. All right. So, excuse me. When we take a measurement in the lab, we're not only communicating an amount or a measurement, we're also communicating how sure we are of that or how much certainty we have in that measurement. So when you write down a measurement, it needs to communicate 2 things. It needs to communicate the actual number, but then also the uncertainty. So when we write a measurement like 2.3, let's say 2.3 centimeters. We measured something as 2.3 centimeters. So that doesn't mean exactly 2.3 centimeters. Even though that's what we wrote down, it's not an exact number. It's a measurement, and it is subject to the limitation of the tool that's doing the measuring. Some tools are more precise than others and are going to give you better precision, less uncertainty in the measurement. But it's not exact. What this measurement really means is that this is somewhere between 2.2 and 2.4 centimeters. Another way of saying that is plus or minus 1 on the last digit. All right. So whenever we write down a measurement, we write down a certain number of digits. That last digit, we can assume that measurement is between plus or minus 1. Now, depending on the tool, some tools that's not true for. And a good measurement tool, I'm just looking at my graduated cylinder, which doesn't say, but a good measurement tool will say plus or minus however much. If it doesn't say, then you can assume it's plus or minus 1 on that last digit. All right, so what does that mean? Why is that important? That means that saying 2.3 is very, very different different color to use a different color to emphasize that it's different. It's very, very different from saying 2.30 centimeters. All right. Now you type both those numbers in your calculator, they're going to treat it in the same way mathematically. Mathematically, those numbers are the same. But when you're reporting a measurement, those numbers are not the same. And here's why. Let's take a look at this definition again. That up so you can see. If 2.3 means that we're saying it's between 2.2 and 2.4, then 2.30 means that we're saying it's between 2.29 and 2.31, right? Plus or minus 1 on the last digit. And now look at those two ranges. The range between these two is 0.2 centimeters, so 2 millimeters, the range that we're reporting here. So we're saying our number is somewhere in between those 2 millimeters. Now in this next one, we're saying that our number is between these 0.2 millimeters, or 2/100ths of a centimeter, or 2/10ths of a millimeter. So this measurement is 10 times more precise than this one. 2.30 is 10 times more precise than 2.3. And so you can imagine if we then said 2.300 or 2.3000 or something, we're reporting more and more narrow precision with our measurements. Right? Less and less uncertainty. So that means that when you take a measurement with a measuring tool in the lab or at home or whatever, you can't just decide how many zeros you want to put in there because you like that many zeros. You have to use some rules to actually write down the correct number of zeros. And what we're going to work on today is how to do that. So if we take apart a measurement like this, we look at it a little bit more closely, what we're really saying is that, this will make more sense once we look at a tool, but what we're really saying is all the digits that are not the last digit are what we call certain. We're absolutely sure. There's no arguing about it. There's no discrepancy there. Anybody who looks at that must be sure that that is true. And I'll show you why that works when we get to that. And then that very last digit is called uncertain. So that last digit ends up being a little bit of an estimate that the person doing the measuring has to make a guess at or make an estimate at. So we've got our certain digits and our uncertain digit. So up here at the 2.3 measurement, the 2 would be certain and the 3 would be uncertain. So there's always just one uncertain digit, and then there can be as many certain digits as necessary. And then all of those together, the certain and the uncertain digits, are all called significant. Significant digits or significant figures. If you took a physics class or something in high school, maybe you talked about how to do mathematics with significant figures. I remember when I learned that, it never really made much sense because it just seemed really arbitrary. But now I understand. It's because when you make measurements with a particular tool, you can't all of a sudden get more precision just because you divided two weird numbers and now you have a whole bunch of decimal places. So all those arithmetic rules, which if you haven't heard them before, don't worry, we're not going to use them in this class much, but if you did use them before, it's a way of communicating that your certainty or your precision of your measurement doesn't change as you do mathematics on it. So we're going to focus on just taking these measurements. And whenever we take a measurement, we always want, we'll say rule. Okay. Our rule is when we take a measurement, we will always take all certain digits plus one uncertain digit. So whatever you were doing, we're always going to take all the certain digits and then we're going to always go one past that. And we're going to call that an uncertain digit. So always one uncertain digit. All right, let's look at how that looks with some examples now. So you can see here, I've got a paperclip, a red paperclip, and I'm measuring it with two different rulers. Now, both of the rulers are in centimeters. But as we will see, the measurement that we write down is different because the centimeters have slightly different precisions of scale. So this are the rulers. This ruler has markings every centimeter, and this ruler has 10 markings per centimeter, which means it has markings every 10th of a centimeter. So let me zoom in a little bit so we can get a good picture on this paper clip. Get a good sense of where it is and how big it is. All right, so we're going to be using this top ruler first. So looking at the top ruler, here's how you take a correct measurement. First, we want to find all the certain digits. We do that by looking at the tick marks on the ruler. So in this case, what we would say is this ruler is definitely between 2 and 3 centimeters. All right, you agree with me? Hopefully you do. I know that it seems like we can debate about things that are extremely true these days, but I think that nobody would say that this ruler is not between 2 and 3 centimeters. So everybody agrees it's between 2 and 3 centimeters. And that's why we call it certain, because there are clear lines here in the ruler that say it is definitely between here and here. I didn't line those up exactly right, but you know what I'm saying. It is definitely between 2 and 3. So when we say that this measurement is 2 point something, we know that's absolutely true. That's certain. It's definitely between 2 and 3, so that makes it 2 point something. Now the something, if we're looking at this ruler here, is not so clear anymore because we don't have little lines to tell us what that something is. So one person might say, oh, that looks like 2.3, and someone else might say, nah, it looks like 2.2 to me. And someone else might say, oh, it looks like 2.4 to me. So depending on how you look at it, how you're judging it, you have to make a judgment call here. You have to decide, do I think this is 2, 3, 4? And all of those are actually correct because that final digit is uncertain. So the 2 is certain, the final digit is uncertain, and we can call it whatever we want. So it looks like a 3 to me, so I'm going to say 2.3 centimeters. So just like our measurement example above, that means that what we're really saying is this paperclip is between 2.2 and 2.4 centimeters long. So we're communicating a measurement, but we're also communicating a degree of certainty in that measurement. Nobody would say this is 2.1 because it would have to be way over here. Nobody would say it's 2.5 because that's halfway, that's over here. But people would disagree if it's 2.2, 2.3, 2.4. So we can pick any one of those and it's fine. All right. I wish I could see all of your faces right now and see if this is making sense. But if it's not, just leave a message or send me something. All right. So how does that change then if we go down to the next ruler? We've got the same paperclip, but now we have a different scale. And again, I'm gonna zoom in even closer so we can see that scale really clearly here. Ah, great, thanks. Thanks, Alex. All right, so now you see the same paperclip, but now our ruler gives us some more lines. So now you can see, hopefully this is coming through in high enough resolution, that you can see that the end of the ruler is between this line and this line. Because it's definitely between those lines, that means we have another certain digit. So it's not just 2 that's certain here. It's also the 3 because it is definitely between 2.3 and 2.4. So here's 2.3 and here's 2.4. And this ruler measurement is definitely in between those. So now it's 2.3 something. And once again, we need to make an estimate for that final uncertain digit. Now this one is really it's hard to tell, right? It's hard to see. I would say it looks like it's on the left side of in between. It doesn't look exactly halfway. So I'm going to call it another 3. But maybe to you, as it's coming through on your screen, maybe you're looking at it on your phone, I don't know. Maybe it looks like it's right in the middle. So you call that 2.35, and that's okay too. That last digit is uncertain. It's estimated. All of those digits are considered significant, but the last one is uncertain. So if we zoom back out here now that we've got our measurement, again, what this means, as we said with the first one, what we're really saying is this is between 2.2 and 2.4 centimeters. And with the bottom one, what we're really saying is this is between 2.32 and 2.34 centimeters. So we've communicated a different level of precision here. And that means that depending on which ruler you were using, these are not interchangeable measurements. So you could not say 2.30 for this top ruler. That would be incorrect. That has to be communicated as 2.3. Similarly, this would be incorrect to round down to 2.3. This measurement needs to be 2.33 because that reflects the precision of the device doing the measuring. So not 2.3 or 2.330 or something like that. It has to be 2.33. It could be 2.32 or 2.34, but it has to have 3 significant digits communicated, 3 significant figures. All right, so that's going to be the case for every measurement you make on any measuring tool, whether it's a ruler, a graduated cylinder, a buret, whatever. The only time you don't have to do this is if you're using a digital tool. Like if we were in lab and we were using the balances, you'd weigh something on the balance and then it would just say a number, 2.33 or whatever on the little screen. That's because that uncertainty is already built in there. So you just write down all those digits. We should also note though, when you're working in a lab like that, when you're getting a readout of some data, it's really important that you don't just arbitrarily round that. So if the balance says 2.3456, you can't just decide, I don't want to write all those numbers down. I'm just going to say 2.3. It's not appropriate to round like that because you're losing that precision in that instrument if you do so. So it's important to always report the correct number of digits for your tool that you're using. All right, so let's take a look at a graduated cylinder, much like what you will be measuring on. Now, graduated cylinders, a couple of things we have to deal with here. One is that when you put liquid, especially water, but all liquids will do this to some extent, when you put liquid in a thin tube, those water molecules are going to interact with the sides of the tube. And that means that the edges of the sample are going to be a little different than the middle. In the case of water, glass has a similar chemical structure to water, so the water can creep up the sides of the glass. So if you're measuring water in a thin tube like a graduated cylinder, it often makes this curved shape. And we want to make sure always to measure from the very middle. The middle is the part that is not affected by the chemistry. And so that's where we're going to want to do our measurement from. Other substances, like nonpolar substances, depending on the thickness of the tube, will sometimes go the other way and they'll make a hump in the middle. And it's the same idea. The edges are sort of pulling away from the glass because they don't interact chemically with the glass. So I guess it's really the opposite. But if you always measure from the middle, that's a good way to always make sure you're consistent in your measurement. So depending on, that way we don't have to worry about like how big the tube is or whatever. We're always just going to measure right from the middle. So whenever we see that curve. The other thing we have to deal with here, unlike with our ruler, we don't necessarily know the scale. We know it's in milliliters, or we're assuming it's in milliliters here. But we've got some numbers marked, but not every number marked. So we have to figure out what the other numbers are. We can't just assume that. So in this case, we've got 15 and then 20, and then there's 4 marks in between 15 and 20. So that tells us that this must be 16, 17, 18, and 19. All right, so that one's not so hard. Sometimes it's not as clear. Just looking at the plastic graduated cylinder like you have in your kit, there are whole number milliliters that are labeled with numbers. And then there are 4 tick marks in between each number. So you're going to have to figure out what those are so that you can get the correct measurement there. All right. So now we know those. So this is going to be 16. Oh, I don't know. My pen started looking weird. 16, 17, 18, 19. All right. And so now that we have those and we have the middle, we know this is going to be our measurement spot right here. Right in the middle of the thing. The word for that is meniscus, by the way, if you haven't heard that before. And so now we can make our measurement. And once again, we're going to look for the certain digits and the uncertain digits. So we know definitely this is between 18 and 17. It doesn't matter which one's on top or bottom. I think it's helpful to just say it's between 17 and 18. And you'll see we're going to use a different tool that kind of flips those numbers. So if a number is between 17 and 18, that means it's 17 point something. So 17 point something. And the 1 and the 7 are certain digits. We know it's between 17 and 18. And then we're going to guess for that final one. I'm going to say it's just above halfway. So I'm going to call that 17.6. If you said it was halfway and you said it was 17.5 or you said it was 17.7, that's fine. Remember, that's an estimated digit. So 17.6, that's our measurement. Notice for all of these, we always have one digit past what the little markings on the instrument tell us. So in this case, we had a mark every milliliter. So we went one digit past that. In the rulers, when we had a mark every centimeter, we went one digit past the centimeter. When we had a mark every 1/10 of a centimeter, we went one digit past that. And usually this kind of makes sense and people do okay with this until something happens. And the thing that happens is what happens when you have a weird tool or when it's exactly on a line. So let's take a look at this tool. This is called a Buret. And there's an eye picture there, but that's just saying you have to be at eye level to actually see the correct measurement on these things. It's a good idea with graduated cylinders too. Really, any liquid measuring tool, you want to make sure it's on a flat surface or it's hanging straight and you're looking at it exactly eye level, because if you're looking down at it from above, you're going to take that measurement at a different point. So even when you're like cooking or whatever, and you've got your measuring cup out, it's a good idea to get down and actually look at it eye level. All right, so back to this thing. Let's try to make this measurement. So first, I'm going to just pause for a second, and I want you to give it a try before I go through it. This is a new type of tool. We don't know what the precision is going to be. Let's see if we can figure it out. See if you can figure it out. So if you're following along right now, I'm just going to stop talking and give you a chance to do it. If you're doing this later, you can do the same thing, or you can pause the video. But give this a try. See if you can do it. If you want to drop your measurement in the chat or on Discord, you're welcome to. If you don't want to, that's okay too. But see if you can write something down, and remember you want to try to get the right number of significant digits in your measurement. All right, I'm not seeing any measurements, but I'm going to guess you had enough time to try to get one. So here's how I would do it. All right, I've got this new tool. First, I want to figure out what my scale is here. So I've got 20, which is this line. I've got 21, which is this line. So that means that I've got like 9 ticks in between here, right? So that's going to be 20.1, 20.2, 20.3, 20.4, 20.5, 20.6, 20.7, 20.8, 20.9, and 30. So we know for sure that this number is going to be, or not 30, 20.9 and then 21. Yes. Okay. So we know that this number is going to be 20 point something because it's in between 20 and 21. Now notice that the scale is opposite of a graduated cylinder. A graduated cylinder would be 19 would be down here and then 20 would be up here. So don't get fooled by that. Your measurement is always between some numbers. It doesn't matter what orientation it was, right? If you tipped your ruler upside down, you'd still use it the same way regardless of the orientation. So this is just between 20 and 21. So if a number is between 20 and 21, it's 20 point something. Now, here's where it gets sometimes an issue, because if we're looking at this directly, we would say, well, it's right on that line, right? The meniscus is exactly on 20.1, 2, 3, 4, 5, 6, 7. So does that mean that it's done? That we say, yeah, it's 20.7, that's it? Not quite. Remember our rule. Our measurement always has to have one uncertain digit past the tick marks. And you might say, well, there's nothing uncertain about this. I know it's exactly on that line. I'm certain of it. Does that just mean I put as many zeros as I want because I know it's on the line? No, that's not the right answer. What you need to do is think about what we just said before. We always write, what's the rule here? We always write all the certain digits and one uncertain digit. So how do you do that if it's right on the line? Well, think about your markings. The markings here are in the tenths. So 20.7 is a marking. It is a mark. If this were in between two marks, you would put another estimate here, right? If this were like a little bit lower, you would put 20.71. So if it's right on the line, you still have to have the same amount of precision. So this needs to be 20.70. All right, so instead of saying 20.7 something, you say 20.70. And that's kind of a trick that you can use to make sure you get the right measurement, is to say, okay, what if this weren't on the line? What would I measure it if it were in between? And make sure you have the same overall number of significant digits. So this is a measurement with 4 significant digits, 3 are certain, and 1 is uncertain. All right. So that's how you do that. Now going back to the lab's going to have you doing a bunch of this stuff. And it's going to talk a little bit about what I just said. Also, there's also a link to a nice video of someone else kind of explaining it, probably more succinctly than me, and a nice little practice quiz you can check out, and then you can start doing some measurements. So on this packet, some of the measurements are like this, where you just look at the thing on your screen or whatever and write down your measurement as though you were doing it in lab. And then some other things are ones that you're going to do yourself. So here's an example of some mass measurements. You may have some digital scales at home, but we can't really assume that everybody has one of those. So these are what the ones look like in the lab. And again, we want to make sure that when you're using these scales and writing down these numbers, just as you would be in the lab, you write down all the numbers. Don't just round because you think you don't want to deal with that many digits. Make sure you're always writing down all of the digits. So like you'll notice here that the instructions kind of are like we're in lab. So it says measure the mass of an empty 600 milliliter beaker to the proper number of significant figures in the laboratory balance. So you can do that. You don't have the balance, but here we've weighed them for you. So you can write down those measurements in your notebook as though you were actually doing this. Does that make sense? All right. So the other thing is that when it says something about reporting your data to the Google document in Blackboard, that's not going to make a lot of sense for us because we're all like using the same pictures to do those measurements. So in lab, we would all have different measurements and we want to put them all together so we could see each other's measurements. At home, it's not an issue. So you can just kind of skip that part. I should have cut that out, I guess. And then this one, there's a very clearly directed report where you want to answer the questions like there was in the first lab, the chromatography lab. So that's how you complete that. You should be able to do that now with the stuff that we've talked about. All right. So before I say goodbye for the night, I just want to show you what else you can do. Please don't feel like you have to wait until Friday to start the next thing, particularly in this module, because there is quite a bit more and probably more new stuff. I'm guessing the stuff we did last time was a little bit of a review. This stuff should be mostly new. So you're going to want to get going on it. Here are your documents for learning how to draw organic structures. I think it will probably be really useful if you try to go through those on your own first, and then Friday you can bring your questions and I will talk about it. But just as with an in-person class, it always works better if you're a little bit prepared before just like hearing it for the first time. So you can do that now, and the class is really set up that will work. So for the drawing organic structures, you can read this stuff, you can go through these references, and the same thing with the polarity and intermolecular forces topic, which we will then get to on Monday. Now the measurements lab, I left that here also just so you have it, but keep in mind, I guess because of all the pictures, the Word document for this is enormous. It's 133 megabytes. So if you're having trouble downloading it, that's why. I would go with the PDF unless you really want the Word document for some reason. Because the PDF should come right out. The Word doc is gonna take a little while, depending on your connection and your space and all that. All right. Well, I don't see any questions in the chat or the Discord, so I guess I'll say goodbye for the night. Oh, there is stuff. Sorry. I didn't see that new messages were coming in. Yeah, good measuring. Thanks. Okay. Well, again, keep sending your messages if you need anything, and I will see you online Friday. So, bye everybody.